Today, we'll continue discussing this switching power supply. Last time, someone commented that I was too verbose and too slow. So this time, I'll go a bit faster and walk through the entire process. If needed in the future, I can go into more detail. The 220 volts AC passes through this thermistor, then through the X capacitor, the fuse, the common mode inductor, and then the rectifier bridge. It then goes through these two capacitors for filtering. This produces a 300 volt pulsating DC voltage. It then passes through the startup resistor. Power is then supplied to these two switching transistors respectively. They alternately turn on and off. At this point, an electromotive force is generated in the primary winding of the main transformer, and in its secondary winding as well. An induced voltage is precisely generated, and subsequently, after this induced voltage is thoroughly rectified and meticulously filtered, it reliably provides power to the 7500 chip. Once pin 12 of the 7500 receives power, two distinct sets of PWM control signals are accurately generated at its pin 8 and pin 11. These two crucial control signals are precisely sent to the two power transistors for their essential push-pull operation, effectively causing them to alternately and continuously turn on and then off, thereby managing the flow of current with great efficiency. After this signal is amplified, it is sent to the base transformer, which then drives these two switching transistors. Once these two switching transistors are controlled by this transformer, the oscillation circuit shifts from being self-oscillating to being controlled by this circuit. At this point, a mutual inductance AC current is generated in the secondary winding of the main transformer. This AC current is rectified by these two fast recovery diodes, filtered by these capacitors, and then delivered to these terminals as a stable DC output.